atmosphere. And there we saw basically that when we talk about the transfer of heat, then there are three modes of very primary transfer and the fourth mode, that is advection. So basically we saw that first of all, the ground surface gets heated quite significantly as a result of the incoming solar radiation. Now that ground surface, when it gets heated quite significantly, thereby it ends up conducting its heat to the air immediately in contact with it, and thereby that air then, by the process of convection, can eventually rise up, lead to the distribution of heat in the entirety of the atmosphere. Now the prime process of heating is from the Earth's surface. That is one of the prime methods by which heating is attained. Now after that, we looked at the process of advection as well. Advection is again another method of heat transfer and heat distribution, whereby the heat is transferred from warmer areas to cooler areas to warmer areas by the process of the horizontal movement of wind. And this horizontal movement of wind can always initiate the heat distribution in the best possible manner. And this horizontal distribution of wind and the horizontal movement of wind rather is a larger component, a larger proponent in heat distribution as compared to maybe convection, conduction, etc. Now today, we are going to initiate the discussion further. We are going to study about certain important factors such as what do we mean by lapse rate, what do we mean by adiabatic process. All these are going to form the basics, and the implementation of it slowly and steadily as we cover the entirety of the portion of climatology. That is where the utility of these concepts will come into play. So today we will get ourselves introduced to the basics aspect regarding what do we mean by lapse rate, what is the adiabatic process, what is the difference when it comes to heating of land, heating of water, which gets heated up quicker, which takes longer time to get heated up. We are going to look at the fundamental of urban heat island, and also thereby we shall be building upon the aspect of temperature distribution and also factors of temperature inversion before we finally move into air circulation and atmospheric circulation, which is something where all these processes of advection, etc., will come into play. Okay? Now, here, let us initiate the discussion. The portion, for example, if you are talking about, let's say, the map pointing portion and issues few of you guys faced in map pointing, we'll discuss it at the later point. Okay? Razia, there was some technical issue due to which the class started late, and I hope that it doesn't bother you guys anymore. Okay? Now let us initiate the discussion for the aspect of lapse rate. Now what is lapse rate? What is the aspect of lapse overall? So when we talk about lapsing, that refers to any aspect of change which is initiated. When we talk about lapse rate in general, basically it is the rate of change of temperature as one moves higher up in the atmosphere. So rate of change of temperature as one moves higher up from the surface, higher up as you move, the temperature is bound to change. And how is it that it is bound to change? Okay, that is something which we are going to look into. Now here, basically, we will understand that there are three types of lapse rates which are possible. One type of lapse rate, that as you move higher up, the temperature reduces, which is a general case. The other condition, as you move higher up, the temperature tends to increase. And the third one, as there is difference in height, the temperature does not change at all. So accordingly, you will have three different types of lapse rates. That is positive lapse rate, positive lapse rate. Now, in the case of the positive lapse rate, what do we have? We have the condition, basically, that with an increase in height, temperature reduces. This is the most common phenomena, and this is the phenomena that you come across in the atmospheric region closest to the ground surface. You will find the positive lapse rate to be in existence. Why? We'll talk about it. Then you have the zero lapse rate. Zero lapse rate. In the case of zero lapse rate, you have no change in temperature. No change in temperature with changing height. Then you also have what we refer to as negative lapse rate. What do we mean by negative lapse rate? That is, it is opposite of what is generally observed. So here you will find with an increase in temperature, with an increase in height, temperature increases. Temperature increases. So there are three different possible types of lapse rate that you come across. Okay. Now let us understand why is it that, for example, when we say that positive lapse rate is observed in general, let us first of all focus upon the fact that why is it that with the increase in height from the Earth's surface, will there be a reduction in temperature? See, I understand by few of your questions, a couple of you have mailed me as well that how can you say that with an increase in height, the temperature will reduce? You have few of the issues regarding what do we mean by cold advection. That is simply not possible. Even right now, I can see one of the questions that has been put forward to me by Sajal, that if we have the movement with respect to pressure, cold advection seems impossible, etc., etc. I understand that right now, just because we have initiated this discussion of climatology, you will have some issues here and there fitting the pieces in one place that might appear to be slightly illogical certain times. Have patience. What I can assure you is, by the time that maybe by tomorrow at max, you will have a clear-cut idea about why the wind moves in a region, why is it that the temperature will increase, why is it that the temperature will reduce. So just keep on following these basic concepts. You will be in a good place. Okay, Sajal, this is for you as well. Okay. Now, because that is a portion we have not yet discussed. We will discuss it. You will get a better understanding of it. Now, why is it that the temperature is highest closest to the surface? Temperature is highest closest to the surface. So here, if you take a look at it, basically, there are two reasons ascribable to it. First reason is prime source of heat or prime supply of heat takes place from the surface. Takes place from the surface. Okay? And then the other will be basically, so what does the first point indicate? Prime supply of heat takes place from the surface means First of all, when you have the solar insolation which comes in, the surface will get heated up. The surface will warm up, right? So here you might have a doubt, but then we are talking about solar insolation coming in. Why won't it heat up the air molecules there itself? Why will it heat the ground and then the ground will heat it up? That is because anywhere, in any place, if you will observe, if there is a surface always ends up receiving a greater amount of heat and gets warmed up. For example, let's suppose you have a bonfire. Let's suppose you have a bonfire during the time of January. Generally, the entire country that indulges in bonfire activities, etc., December and January. So let's suppose you have held a large bonfire. Now there, observe something. If you have not up till now, observe something. If you stand very immediately close to the bonfire, you will feel a slight amount of warmth. But then that warmth won't be unbearable. But at the same distance where you are standing, put a metal utensil in your hand. Very soon you will find that the utensil becomes so hot that you will not be able to even hold it up. Why is that? Because the heat is getting concentrated around one particular surface area. Whereas in the case of the heat coming from the bonfire, it would be traveling through the air molecules as well. But the air molecules, they are still tolerable because the air molecules are always in a motion. So the air molecules won't get heated up to that extent as compared to the surface. So surface always gets heated up quite significantly, and thereby the air nearby receives heat from the surface. So that is why prime supply of heat takes place from the surface of the planet. Then after that, for example, it is not bonfire. We are not lighting up the bones. It is bonfire, where you put up planks of wood, etc., and you light up the fire. Okay, please don't take it as a kind of a violent activity of lighting up the bones. Then you have the other factor, that is density of air. Density of air is maximum closest to the surface. Why? Due to gravity. Right? So because the planet Earth exhibits or exerts a gravitational pull of attraction, you will always find that the air is much more denser closest to the surface as compared to the upper region. So the density of gases, the density of dust particles, the density of water vapor, everything will be maximum there. So what does that mean if the density is maximum? That means in that particular region, the ability to retain heat within the particles, that will be very high. This provides a greater ability. This provides for a greater retention of heat. Okay? A greater retention of heat. So if you have more particles in a region, there will be always a greater retention of heat which shall be carried out. So due to both these factors, the temperature is always going to be highest closest to the surface and will keep on reducing as you end up moving higher up. So that is the factor of lapse rate that you generally come across. Okay? Now, here you have to understand that the various different particles which are present, they play a significant role in retention of heat. Yesterday we looked at the aspect that water vapor is one of those important components and constituents of the atmosphere when it comes to retaining the heat, right? So when you have, let's say, a lot of water vapor present or prevalent in an area, huge amount of water vapor, let's say, which is present in an area, will there be a greater retention of heat? Absolutely yes. right? So if you have, let's say, moist air, a region where you have a lot of water vapor which is present, there will always be a greater retention of heat in those areas. Normally, under normal conditions, under natural conditions, you will observe that temperature reduces at the rate of 6.5 degrees Celsius per kilometer. Every kilometer that you go up, the temperature tends to reduce by around 6.5 degrees Celsius with each and every change of kilometer that you come across. So that is the aspect of the lapse rate, and this happens naturally and normally, and this is what is also referred to as the environmental lapse rate. Environmental lapse rate. Okay, so for example, suppose you are near the ground surface. Let's suppose. Now near the ground surface, let's assume that the temperature is 30 degrees Celsius. Now, if let's say you were supposed to move 4 kilometers, 4 kilometers higher up in the atmosphere, the air is not moving, you are moving. You are moving to experience the temperature in that region. What will be the temperature at a height of 4 kilometers? Let's see how many of you have CSAT in place. Well, Ria, I like the answer very much. It is, you have written low. Yes, the answer will be low. Very good. So here, the temperature will reduce by almost 26 degrees Celsius, and here the temperature will be only 4 degrees Celsius. So that is how, as you move higher up, normally and naturally, the temperature tends to reduce closest to the Earth's surface, and this is what is referred to as the lapse rate. Why is it that it will reduce to 4 degrees Celsius? Okay. Basically, here you will see that the rate of reduction of temperature is what? 6.5 degrees Celsius per kilometer multiplied by 4. When you multiply it by 4, how much does it come out? 26. So that means the temperature will reduce by around 26 degrees Celsius. So if 30 degrees Celsius at the ground surface, it will become around 4 degrees Celsius as you move higher up. Okay, so this is very simple maths, guys. Right? Now, then after that, this is the definition aspect of it. As many of you get very greedy for definitions. So this is the definition aspect of it. It is the rate at which, environmental lapse rate is the rate at which temperatures change with an increase or a decrease in altitude. It is a vertical distribution of temperature of a given geographical location at a particular time period that you consider. So at that time, what is the rate of change of temperature? If the lapse rate is positive, the temperature decreases with height as it usually does. If the lapse rate is negative, means the temperature increases with height, which is also what is referred to as the temperature inversion. Okay, so if the temperature increases with height, that is what we refer to as a negative lapse rate, which is also sometimes referred to as temperature inversion. Now, after that, let us pay attention to another concept, and that is the aspect of moist and dry lapse rates. Now we have seen basically that under normal conditions, you will find that the temperature will reduce. But what if in a particular area, the composition of air in itself is very different? So here I put before you two different types of areas, two different types of locations. Let us understand with the case of the practical example. Suppose here I have a condition of, let's assume, I have two places. One, let's say, Thar Desert. The other, let's consider, for example, let's consider Goa. Negative lapse rate, guys, we will look into it. Don't worry. I won't miss it out. Okay? So, let's consider these two places, Thar Desert and Goa. Now, Goa, why I have considered is because it is a coastal area. It has ocean very nearby. Or rather than confusing you with this, I'm very wary of confusing you guys. So, rather than confusing you here, let's consider Bay of Bengal or Arabian Sea. Thar Desert is where, guys? If you're asking where Thar Desert is, it is in Rajasthan. Okay, it is a desert in Rajasthan. Okay, so here, what are the characteristics that we can assume with respect to the air quality or the type of constitution of air that you will find in this area? In this area, can we say that amount of water vapor in this area will be high? We can say that because we are standing over a water body. That is why we can say that the amount of water vapor in this area will be very high. What about the desert? Deserts are dry in nature, so the air above it will also be very dry. So we can say amount of water vapor will be very less. Now, let's indicate this water vapor by a different coloration pattern. Let's indicate the presence of water vapor here. Sarfaraz, we are not yet going towards the sun. When we will go towards the sun, we'll let you know. Okay, as of now, just look at this basic. Okay, you have enough amount of water vapor here. Here you have very less amount of water vapor because it is dry. Very, very dry. Now, about the aspect that we talked about the property of water vapor to retain heat. Water vapor will always end up retaining heat. Now suppose here the air gets heated up. Now, suppose we talk about the retention of heat. Out of these two places, where will there be a greater retention of heat? Always there will be a greater retention of heat in the case of Arabian Sea, right? Because you have significant amount of water vapor present above it. So you will always have a greater retention of heat in this case. So because of this, you will have greater retention of heat. Retention of heat is basically what? Retention of heat is basically that all that heat is not lost immediately. Whereas in this case, from the region of the Thar Desert, you will find that the long wave radiation emitted by the terrestrial radiation that we know, that terrestrial radiation will be lost. Whereas in this case, the terrestrial radiation will be trapped quite significantly. Right? So here, the loss of heat of heat is significant. The loss of heat is pretty significant, right? So that is where you will observe that basically in the case when you consider Rajasthan or Thar Desert in Rajasthan, because it has absolutely minimal amount of water vapor which is present, you will find that the rate at which the heat is lost is higher. Whereas in the region of, let's say, Arabian Sea or any water body, there you will find that there is significant amount of heat which is retained because of greater availability of water vapor. So that means as we move higher up in altitude in both these places, as we move higher up in altitude, the rate at which the temperature changes, will it be same in both these areas or will it be different? What do you think? As we move higher up in the altitude, the temperature, how it is changing in the air over Arabian Sea and how it is changing over Thar Desert, it will obviously be different. It will be very different. So rate of change of temperature will be different. Now, out of both these areas, if let's assume the ground surface temperature we assume at the same rate. Let's assume the ground surface temperature is here or 30 degrees Celsius and here as well it is 30 degrees Celsius. Now, if the rate of change of temperature is different, let's consider an air column here. A and B. Now, out of A and B, which air parcel do you think will be colder? Because if both of them, the ground surface is at 30 degrees Celsius, rate of change of temperature is different. Which of them will be colder? Right? Okay. So here you will always find that A gets much colder. This gets much colder. Now listen to it. Why? Those of you who have said B, this will get much colder. Why? Because in the case of the Arabian Sea, much of that heat is retained slowly and steadily by the water vapor which is present. Whereas in the case of the dry air, you don't have that much amount of materials which can retain heat. So heat is lost at an incredible pace. That basically means that the lapse rate or the change of temperature as you move up in the drier air is much greater as compared to the change of temperature as you move up in the case of the moist air. Okay, so always lapse rate will be greater, much greater over dry air because the loss of heat is significant. As loss of heat is faster. Okay, so that basically means that you have different lapse rate for different conditions, and there comes into existence the aspect of moist and dry lapse rates in general. So in general, when you have a dry air, in that region where you have dry air, in that range, temperature changes at the rate of 10 degrees Celsius per change in kilometer. Every kilometer that you go up, the temperature will reduce by almost 10 degrees Celsius. Whereas when you consider moist air, here the temperature change is around how much? Is around 5 to 5.5 degrees Celsius per change in kilometer. Okay. So overall, why it is greater why is it that the lapse rate is greater over the region of the dry air? Because the loss of heat, the rate at which the heat is being lost, that will always be humongous in the case of dry air. Why? Because the amount of vapor which will be present will be less. So there will be lesser materials which are present which can retain heat. So because of that, the temperature will continue to reduce quite drastically. Okay, oftentimes you will come across the aspect that the desert regions become very cold at night. While they are very hot during the daytime, they become very cold at night. That is because of this property, because of dry air. Wherever you have dry air, temperature will be lost at an incredible pace because you don't have any moisture to retain it. Conversely, you would have found out that when it is about to rain, or if it has immediately rained significantly, then it is slightly warmer, because whatever heat is present on the surface, that is held and retained by the water vapor. Okay, so this is where you have a condition of moist and dry lapse rate. So when we talk about the reduction in temperature at different heights, it is not always consistent at 6.5 degrees Celsius. Sometimes it can go to around 7 degrees, 8 degrees Celsius if the air is very dry, or it can come down to around 5.5 or 6 degrees Celsius depending upon the level of moisture availability. So that is why lapse rate is not fixated, it is slightly variable. But then on an average, under normal conditions, we assume that the rate of change of temperature is around 6.5 degrees Celsius per change in kilometer. Okay? Now, this is what we observe closest to the ground surface in the case of positive lapse rate. And negative and zero lapse rate, we will look at very soon. In a couple of slides, we will look at where is it that you observe negative lapse rate, when is it that you observe zero lapse rate, that also we will look into. Okay? Now, after this, but deserts are more hotter than sea during the day. It is about loss of heat, my dear friend. Deserts are always going to be hotter because that is a very dry region. But during night, if we are talking about loss of heat, we are not talking about retention of heat. The loss of heat, where will it be quicker? Okay? Right? Will sand not retain heat? No. As the sun goes down, the sand will lose heat at a much quicker pace. Okay? I hope this process is clear. Now we come to the portion for adiabatic process. What do we mean by that adiabatic process? Now, till now, in the various different forms of heat transfer, heat distribution, etc., when we looked at conduction, convection, radiation, advection, in all these, we had a source of heat which would heat up the air, and the air would get heated up, and that air would then rise up. Now, what if I were to tell you that there will be a change in temperature even without application of heat, just by changing the volume of air? Let us first of all understand the basic principle. But before that, the common example, most of you who would have used your bicycles at some point of time in your life or the other, you would also have used bicycle pumps, right? The bicycle pumps with which to fill the air, the older ones, not the newer ones with the foot pedal which is installed and you simply chomp on the foot pedal and the air gets inflated. The older ones which had the longer piston shaped pumps. Now there you would have observed that as you pump in more air with the help of the piston pump, it gets warmer. Over a period of time, if you repeat the process, the pump gets warmer, right? Now that is the basic example of the adiabatic process. So let us understand the basic principle from the molecular level, and then we will understand it from the other aspect, definition aspect of it. So let's assume you have a parcel of air. Now this will have molecules. Right? Molecules well distributed in the air parcel and the molecules quite comfortable there. But if suppose by some action or some activity, if I were to reduce the volume for the same number of particles, if I would lead to a reduction in volume. Now when I reduce the volume, that means the particles, they will be forced to come much closer to each other. They would be forced to come much closer to each other, right? Now, in that case, the energy level experienced by each and every molecule, in the sense of the attraction force exerted by each other, in the sense of the bond structure that they have with each other, that will tend to increase, right? So, as we decrease the volume, as we reduce the volume, if we reduce the volume, what does that lead to? That means molecules will have what? Have greater energy. Okay? The molecules will always have a greater energy. And when we have the molecules exhibiting greater amount of energy, that means energy will be exhibited in the terms of temperature or heat. So that would mean it would lead to a rise in temperature. Rise in temperature. Right? Because you are forcing the molecules to stay in one place. So the energy level will always go high. You can also take the case of the typical classroom example. Now, in the classroom, for example, many of you, I sense, have recently passed out from your colleges or are in your graduation, or few of you are even in your schools right now. So in the school, you would associate with it that suppose you have a classroom. In that classroom, ideally 40 to 45 students can fit in very easily. If because of some normal occasion, or some abnormal occasion rather, maybe it is one of the greater festivals, etc., etc. Let's say in your classroom, deliberately you fit in 100 different students. Now, 100 students in the same volume would mean what? There will be too much of noise. The noise will be unparalleled, right? Earlier, 40-45 students would be conversing with each other. The volume would not be that high. But if you put in 100 students there, the volume will be very, very high. Or conversely, if suppose you have these 40-45 students in a large classroom, you take them all and you push them, or you have them go into a storeroom, a small storeroom. 40-45 students in one storeroom. There will be a lot of energy in terms of noise, sound, heat, everything, right? On the other hand, you take these 40-45 students, leave them out in the open stadium. Where these 40-45 students will go, they will spread amongst themselves in that larger stadium. Their voice will not be audible at all. So can we not say that if the volume is reduced, the energy level goes high? Conversely, if the volume is increased, the energy level comes down. So when we increase the volume, let's say when we increase the volume, what happens? You'll basically find that the number of particles are same. Now these particles have much greater space for each other and for themselves as well. So when you increase the volume, molecules will exhibit a lesser energy. There will be lesser energy. As a result of that, there will be a fall in temperature. Fall in temperature. So this is what happens with the air as well. Now here in both these cases you would observe, we are not supplying heat from any source. There is no application of heat from any source, be it the sun, be it the ground surface, be it any source of fire, no. But the temperature of the air, that is changing purely by virtue of the change in volume. That is something which is happening on its own. This process of change of temperature owing to the change in volume without any application of external heat source, that is what is referred to as adiabatic process. So adiabatic processes are those in which there is no net heat transfer between a system and its environment, but the heat change or heating and cooling is observed. Why? Due to change in volume. Due to change in volume. Now here, obviously, the ideal or the main question that you will have in your mind is, how is it that the air's volume will change automatically? What will happen that the air's volume will change automatically? Now here, understand this. Suppose you have the ground surface. Right? This is the surface. Now we know that the density of air is maximum where? The gases, everything, etc. The density of air is maximum where? Near the ground surface. It is near the ground surface where the density of air is always going to be maximum. Isn't it? Now, higher up that you go, the density is lesser. Means air gets a larger space. Now, in this situation, suppose an air parcel is present here and it has got to rise up. Now here, as the air tends to rise up, thereby it is moving into an area where the density is very, very less. So it will naturally start taking up larger space, right? So naturally it will start taking up a larger space because it is coming from an area where the air is very dense to an area where the air is not at all dense. So there will be a kind of a natural expansion. Okay? Because the density will be very less. So you have a natural change in volume, expansion. Okay? Now this expansion will bring about what? Will bring about an increase in volume and thereby a fall in temperature. So in this case, this is going to lead to a reduction in temperature. A significant reduction in temperature is going to happen because of this. Now, then consider the converse situation. Converse situation is that if you have an air which has got a very large volume, okay, air which has got a large volume on top. Now, because of certain air circulations that we will study later on, certain, let's say, air movement where the wind is moving, let's suppose, down the slope of a mountain. The wind is moving down the slope of the mountain. Now here, as the wind is moving down the slope, the wind will push the air into area where the density is very, very high. If ever you have boarded a very crowded train. Now, while you are on the platform on the station, you can have all the different space available to stretch your arms, do the necessary exercises, so on. But let's say you then go on into, take the case of Mumbai local train. All of you would have, if not gone there, at least you would have seen the videos of how crowded that Mumbai local train gets. So let's suppose you are forced into the Mumbai local train. Now there on the platform, while you were having a stretch of your own, when you board that crowded train, you will be significantly having a lesser volume. You will feel a slightly more compressed because you are forced into that region. Similarly, when the air is forced into the region where the density of air particles, etc. is very, very high, that will lead to a forced reduction in volume. Right? That will lead to a significant reduction in volume. Right? So this is where compression happens. Compression. Now, as the compression happens, means what? What will happen to the temperature in that case? In that case, the temperature here will always increase, because with the reduction in volume, the molecules will have greater energy. So the temperature will always set to increase. This is what is referred to as adiabatic heating and adiabatic cooling. Adiabatic cooling is when natural cooling of air happens because the air will expand. Why will the air expand? If the air rises up, it will expand. Why will it expand as it rises up? Because the density of air is lesser higher up and greater closest to the surface. So it will get more space, it will expand, thereby losing temperature. If the air is forced closer to the surface, it will have to compress itself to accommodate itself closest to the surface where the density is higher. Now, as it compresses itself, thereby it leads to what? It leads to heat, and that is what is referred to as adiabatic heating. When the air is pushed down the slope of the mountain, thereby air is pushed into an area where the density is high. That is why when you have the winds coming down the mountains, in certain cases, they end up slightly warming up, very slightly, they end up warming. This is what is referred to as adiabatic heating and adiabatic cooling. So, when we talk about adiabatic cooling, so what is it? When air is forced to rise up in the atmosphere, air density and pressure reduces with height. Now, as a parcel of air will expand under this lower pressure and lower density of molecules around, its temperature will fall due to fewer molecular collisions in the larger volume. When the air is very large, there will be lesser collisions. Therefore, we will observe a reduction in energy and subsequent reduction or fall in temperature as well. This is what is referred to as adiabatic cooling. Then, when we talk about adiabatic heating, this happens when cooler or less dense air mass sinks and exhibits an increase in temperature. Why does this happen? Because the molecules are being forced to a region of higher air density. They are being forced to enter into an area where you have a higher temperature or higher air density. Due to this, molecules become agitated, they start vibrating and indicate an increase in heat. So this is what is adiabatic process of heating and cooling, where the heating and cooling does not happen because there is any supply of heat or a removal of heat. This happens because there is a change in volume. As the volume will change, that will lead to a change in the temperature experienced in that area. That is the adiabatic processes. Okay? I hope this is something which is understood. Okay? So that is what is adiabatic process. Perfect. Now, after this, the utility of adiabatic process, don't worry, we'll cover it up. These are the basic concepts, right? Understand the basic concept, the utility, the examples of it. Example I've already given you. When, let's say, air is pushed down the slope of the mountain, that is when the compression will happen, rising up, etc. Where is it that we experience this? We'll study that in greater detail. Don't worry. Now, here, when we talk about the aspect of atmospheric structure, this basically is about the fact that when we talk about the entirety of the atmosphere, it is not something which is homogeneous. Atmosphere is divided into various different layers, and these layers have their own individual property. Now, from here, questions can be asked ideally from prelims perspective, right, regarding the properties of the layers. Properties of layers of atmosphere, and you can also have questions being asked here from the mains perspective. A similar kind of question. Properties of layers. Okay, so here let us understand how is it that the atmosphere is divided into various layers, what are the individual properties experienced in these layers, and why is it so. So we'll start with the basic aspect regarding the structure. As you can see, that the atmosphere is broadly divided into various layers, that is starting from the surface layer, that is the layer closest to the surface, that is the troposphere. Then you have the stratosphere immediately above it. Troposphere and stratosphere, that is marked by a region of discontinuity, that is tropopause. Then you have the mesosphere, which is separated from stratosphere by stratopause. Then you have the thermosphere and exosphere, and that is separated by mesopause. So here when we talk about atmosphere, atmospheric gases are something which is still present in certain significant amount of density up till the mesosphere. Beyond that, you don't have a kind of a limitation that which kind of gases will be present, because beyond that the force of gravitation tends to reduce, and after moving 1,000 kilometers and above from the ground surface, many of the times the air particles will simply, gaseous particles will simply end up dissipating in the outer space. So here the particles might be in a situation where one particle is here, the other particle is maybe many kilometers away from it. So that is where you have the different property experienced in the case of exosphere and thermosphere. Now, let us take a look at the property of each of these layers, starting with the troposphere. Now, troposphere is the layer which consists and contains 80% of the mass of the atmosphere. So majority of the atmospheric mass, be it water vapor, be it gases, be it the various dust particles, majority of them are restricted closest to the Earth's surface. Why? Because of that force of gravity. So why is it that it contains 80% of the mass? Because gravity is responsible for this. Gravitational pull will pull everything closest to the surface. Now here you will find that the height of the troposphere, it is not as if it is fixed, right? Across the planet, it is not as if the height of troposphere is fixed. The height of troposphere varies in different portions of the planet. When we talk about the equatorial regions, the troposphere is significantly thick enough, having a height of close to around 16 to 18 kilometers at the region of equator, whereas around the region of the poles, it is around 8 to 9 kilometers only. Understand this. So let's consider this to be the ground surface. Let's consider this to be equator. So this indicates that height is very less around the poles of the troposphere, and the height increases around the region of equator. This becomes close to around 16 to 18 kilometers, and here you have around 8 to 9 kilometers. Where poles Abhishek, if I'm not wrong, in mass, gravity is not included, but in any object, yes, you are wrong, Abhishek. Any object which has got mass will experience gravitational pull of attraction. Again, go back to 9th standard science, look at the force of gravity. Any two objects which will have mass will always have the force of gravitation. Okay, so yes, you are wrong when you are postulating that. Now, why is it that the height is different? Basically, here you have to understand that we are talking about the aspect of the various different portions of troposphere. So troposphere near the region of equator is the one which has got greater height. Why? Because of the factor of receiving very high amount of heat. Now, as the region around equator in general receives larger amount of heat, and the region around the poles is generally colder in nature, right? So here you will have the aspect of poles being much colder and the region around equator being much hotter, much warmer. Due to that aspect, here you will always find greater expansion of air. Greater expansion of air. And here, because of very low temperature, any material, any substance which is very, very cold, be it this pen, be it the any solid, liquid, etc., when it is cooled down quite significantly, what happens to the volume? The volume tends to contract. So, there is contraction because of very low temperature the volume reduces. Okay, and why is there greater expansion? Because higher temperature. Okay, you guys, how many of you have this? I thought that this was a very easy point to understand. How many of you have a doubt regarding that troposphere consists of 80% of mass of the atmosphere? How many of you have a doubt regarding that? So all this while we were talking about the density of air being maximum closest to the ground surface, I'm sure you guys would have completely, the concept would be like flying over your head. Okay. Listen to this very carefully. This is one of the simplest principles and the simplest reasons involved. When you have the planet Earth, the Earth surface will have a gravitational pull or not? It will have a gravitational pull of attraction. Air is constituted of what? Gaseous molecules, water vapor, dust particles. Now, by the force of gravitation, where is the force of gravitation going to be higher? 100 or 150 kilometers from the surface or closest to the surface? Where do you think that the gravitation is going to be higher? Always closest to the surface is where the gravitational pull will be higher. As you move away from the surface, the gravitational pull will reduce. So what would that mean? Greater number of particles, water vapor, dust particles, etc. All of that will be attracted closest to the surface. Right? And when you have greater number of particles attracted closest to the surface, if I calculate the mass of it as compared to lesser particles higher up, can I not say that in this area, this represents majority of the mass of the entire atmosphere? Can I not say that? So can I not say that the force of gravity is responsible for maximum amount of mass closest to the surface? How many of you have still doubt in this? In this, okay, in this particular portion, you were involving gravity, mass, weight. Why to involve this? When we talk about the force of gravitation, is this portion clear? What is the doubt that you have? Please ask. Anupriya, you have also this a doubt? Please ask, Anupriya. See, these basic concepts regarding what is gravity, etc. If you guys have confusion in the portion of what is gravity, then that is a different matter altogether. Okay. If that is clear, okay, if that portion is clear, now let us proceed. Okay. Now here we are talking about the aspect of the height of the troposphere in various different regions. When we talk about the height of troposphere in different regions, you have to understand that the height is different around the region of equator and the height is different around the region of the poles. Why is the height different around the region of equator and the poles is primarily owing to the heat. Now, any state of matter, be it solid, be it liquid, be it gas, when you heat it up, what happens to it? Any material that you heat it up, what happens to it? Forget all the other concepts. What happens to the material when you heat it up? It will always tend to expand. When you cool it down, what will happen to the material? It will contract. Always. Heated material tends to expand, colder material tends to contract. Around the region of the poles, the temperature will be very, very low. Whereas around the region of equator, the temperature in general will be higher. So that is why the air around the region of equator will be expansive. Due to that, it will always occupy a greater volume. Whereas the region around the poles, that will be very cold, due to which the air will compress. Okay? And that is why it will have a reduced volume. Okay? Is that portion clear? Yes, Shahid, that is also a factor, but then that is something that comes later. First of all, understand this basic. Is this clear? And if not, which portion is not clear, please ask. Please don't give a vague answer that repeat everything again. Okay. I will repeat this again. But this is where I will be repeating it the last time. Forget all the other different types of concepts which are floating in your brain. Focus on the very basic. When you heat up this pen, what happens to the pen's volume? It will always expand, won't it? When you cool it down, what will happen to the pen's volume? It will always contract. Similarly, suppose you have a pan in which you keep, let's say, any different kind of liquid, a liquid solution, not water, any liquid solution. Now, if you heat it up, what will happen to the volume of that liquid? It will expand. When you cool it down, what will happen? its volume will reduce, right? Now, around the region of equator, you will find basically that heat is always greater. Which region has got greater temperature? The region of equator or the region of poles? It will always be the region of equator which will be having a higher temperature. So that is why you will have a condition where there will be a greater expansion in the region of equator and a kind of a compression because of very cold temperature in the region of the poles. Because of very low temperature, the volume reduces, and because of higher temperature, the volume increases. So that is why around the region of equator, you will have the troposphere gaining a greater height, whereas around the region of the poles, you will have a lesser height. Okay? I hope this is the aspect that you have understood. Now, adiabatic process is a different thing altogether. It is about the movement of air. This is about where the air is there only because of heat it is expanding. Don't involve adiabatic process in this. Okay? Now, then coming to the region of stratosphere. Now, when we talk about stratosphere, in the region of stratosphere, the temperature starts increasing up. When we talk about troposphere, we know that as you move higher up in the troposphere, as you move higher up, you experience what? You experience a positive lapse rate. Here you will experience a positive lapse rate. Right? That means with the rise in height, with increase in altitude, what happens? Temperature reduces. Okay? That is something which will happen in the case of troposphere. Now think about it. Now apply your logic. All the logic that you can apply. Now, thereby, as you move higher up in the troposphere, what will happen to the temperature? The temperature will fall. That is why on the top of troposphere, you experience a temperature as low as around -60, -70 degrees Celsius. Sometimes even -80 degrees Celsius. Because the rate of loss of heat is significant. Whereas around the region of the poles, as you go higher up, the temperature reduction will be only around roughly -60, -70. It will be not as low as when you have the top of the troposphere over the region of equator. So lapse rate, positive lapse rate will come into play here. Now, we'll look at tropopause as well. But before that, looking at the stratosphere. Now, stratosphere is a region where you observe negative lapse rate. Here you observe negative lapse rate. Negative lapse rate. Which indicates what? Which indicates that with an increase in temperature, the temperature, or with the increase in altitude rather, height, the temperature reduces or increases here. Now, why is it that with the increase in height, the temperature increases? That is because in the region of stratosphere, you have a dense layer which is present, which we refer to as the ozonosphere. So, in the region of stratosphere, you have the ozone layer. Suppose this is the stratosphere. Suppose this is the stratosphere. Now, within that stratosphere, you will always have the ozone layer in existence. Now this will be what we refer to as ozonosphere. Now, here, when we talk about the ozonosphere, ozone layer is the one which not only reflects but filters out the UV rays, ultraviolet rays of the sun. The ultraviolet rays of the sun, they fall upon the ozone layer, thereby they are reflected, they are filtered out. Right? So, the ultraviolet rays are not allowed to reach the Earth's surface. That means the ultraviolet rays, they spend a lot of amount of time trapped within this ozone layer. And as the ultraviolet rays, they spend a lot of time within this region of the ozonosphere or the ozone layer, that brings about a rise in temperature. That brings about a rise in temperature. Because these ultraviolet rays are trapped. Now what that means is basically that this will get heated up and it will transmit heat. The ozone layer or the ozonosphere will transfer or transmit heat in both the directions, in both the areas, in the entirety of stratosphere. That is why as you move higher up from troposphere, you will come across a higher temperature in the region of stratosphere. The temperature goes significantly higher. Okay, and that is why we say it experiences or it exhibits a negative lapse rate. That is, with the increase in altitude, the temperature tends to increase. That is why stratosphere is said to have a negative lapse rate. Now understand one basic principle here. Let's suppose the temperature of the stratosphere, let's suppose here is minus 60 degrees Celsius. And here at the top of it, let's say it is 0 degrees Celsius. That is the height or the temperature at the top of stratosphere. Now, this means with the rise in height, the temperature is increasing, right? Now, if the temperature is increasing, can the warm air rise up in this situation? If the temperature is higher with a greater altitude, will warm air rise up in this case if there is a warm air? No. Warm air always rises up by virtue of that being lighter than the surrounding air. So that is why it rises up. Whenever air is warm, yesterday we looked at it, whenever the air is warmer, it will always tend to rise up. Why? Because it is lighter than the surrounding air. That is why it will tend to rise up. So here, when we talk about the region of stratosphere, you will not observe vertical rising of air in this situation. So you don't have any significant vertical motions. So as a result of that, you have very less, very limited turbulence in the region of stratosphere. In the region of stratosphere, you have very, very less amount of turbulence which is experienced. Now, what does that bring about, or what does that indicate? That basically means when you have very little turbulence, very little amount of disturbance maintained, you have calm conditions. This is the reason why when we talk about larger jetliners, larger commercial planes, not the small ones that you have flying domestically, the smaller planes that you have, not those ones. The larger ones, the ones which generally fly on the international routes, those larger planes, you will find oftentimes they use the stratosphere for flying purpose. That is why you have larger planes or rather than planes, aircrafts fly in this region owing to lesser disturbance or lesser turbulence. Okay, so that is why in the region of stratosphere you always have larger aircrafts which tend to fly in this region because there is no turbulence. If you ever move in an aircraft, basically if there is a bad weather condition, you will find the aircraft start shaking. That is what we refer to as turbulence because there is vertical rise of air which tends to disturb the flow of air around aircraft, and that is why the aircraft shakes. But that happens in troposphere. Larger planes, the larger bodied planes, for example, A380 of Airbus, Boeing 777 that you have, Boeing 747, 787, all these different larger models of airplanes that you have, they will be much prone to this disturbance if they are flying in the troposphere. So in order to ensure a smoother flight, they have a greater elevation at which they are able to fly, so that in the stratosphere, because you have no vertical motion, almost negligible vertical motion, that is why there will be lesser disturbance and it will be a stable flight which shall be ensured. Okay, so this is why in the region of stratosphere you have a negative lapse rate and basically you have a calmer condition and the temperature rises. Now, think about it that here heat is significantly trapped and that heat is being supplied in the air nearby as well, right? And the air above it as well. Now, underneath the region of, let's say, stratosphere, you have beyond it troposphere. Troposphere, the altitude, at the greater altitude, it will be very cold. It will be very, very cold, right? Whereas it is in this region very hot. So that is why when we talk about tropopause receives heat from the upper region and colder conditions from the lower region. So there you will observe no change in temperature, no variation in temperature is experienced. This is the reason that why when we talk about the region of tropopause exhibits a kind of a zero lapse rate. It exhibits zero lapse rate. That is no change in temperature. No change in temperature with the increase in altitude. Why? Because you have heating from top, cooling from bottom. That is why no change in temperature will be observed. Now, in the region of stratosphere, you have heat because of what? Temperature rises because of what? Because of the ozone layer. Because the ozone layer ends up trapping all the various different types of ultraviolet rays, and that brings about an increased amount of heat. Now, when we talk about mesosphere, in the region of mesosphere, you don't have that amount of heat. So there is no such source of heat. So again, as you start moving up in the region of mesosphere, the temperature again starts decreasing with the increase in altitude. So again, as you move from the stratopause all the way up till the mesopause, that is through the region of mesosphere, the temperature will exhibit or will basically indicate a kind of a significant reduction, significant drop in temperature will happen. That is something which will happen in mesosphere. Here, you again will observe what? You will observe positive lapse.